Key concepts: construction of free body diagram. The full procedure for drawing a free body diagram which isolated a body or system consists of the following steps. Step 1. Decide which system to isolate. The system chosen should usually involve one or more of the desired unknown quantities. The desired unknown quantities. Step 2. Step 1 is to decide which system to isolate. It is very important. Next, isolate the chosen system. Isolate the chosen system by drawing a diagram which represents its complete external boundary. Complete external These boundaries define the isolation of the system from all other attracting or contacting bodies which are considered removed. This step is often the most crucial of all. Make certain that you have completely isolated the system before proceeding with the next step. The next step is step 3. Identify all forces which act on the isolated system. As and applied by the removal contacting. Identify all forces which act on the isolated system. By the removed contacting. And attracting bodies. and represent them in their proper position on the diagram. In their proper position. On the diagram of isolated system. Make a systematic traverse of the entire boundary to identify all contact forces. Include body forces such as weight where appreciable. Represent all known forces by vector arrows, each with its proper magnitude, direction, and sense indicated. Each unknown forces should be represented by a vector arrow with the unknown magnitude or direction indicated by symbol. If the sense of the vector is also unknown, you must arbitrarily assign a sense. The subsequent calculation with the equilibrium equation will yield a positive quantity if the correct sense was assumed, and a negative quantity if the incorrect sense was assumed. It is necessary to be consistent with the assigned characteristics of unknown forces throughout all the calculation. If you are consistent, the solution of the equilibrium equation will reveal the correct sense. Step 4. Show the choice of coordinate axes directly on the diagram. Pertinent dimensions may also be represented for convenience. Note, however, that the free body diagram serves the purpose of focusing attention on the action of external forces, and therefore the diagram should not be cluttered with excessive extraneous information. Clearly distinguish force arrows from arrows representing quantitative other than forces. For this purpose, a colored pencil may be used. Combination of the foregoing 4 steps will produce a correct free body diagram to use in applying the governing equation, both in statics and in dynamics. Be careful not to omit from the free body diagrams certain forces which may not appear at first glance to be needed in the calculation. It is only through complete isolation and a systematic representation of all external force that a reliable accounting of the effects of all applied and reactive force can be made. Very often a force which at first glance may not appear to influence a desired result does indeed have an influence. Thus, the only safe procedure is to include on the free body diagram all forces whose magnitude are not obviously negligible. The free body method is extremely important in mechanics because it ensures an accurate definition of mechanical system and focuses attention on the exact meaning and application of the force laws of statics and dynamics. Review the foregoing 4 steps for constructing a free body diagram while studying the sample free body diagram shown in the next videos and the sample problems which appear at the end of the next article. So the next video is about example of some free body diagrams.